Hello class. Now that we're done with law of sines and law of cosines, we're going to move into the next section starting today. The next section is going to be section 6.5. And before we even get into 6.5, there are two skills that I want us to review. One is finding the absolute value of a complex number. So the absolute value of a complex number can be found using the formula square root of a squared plus b squared, which, as we discussed the other day, is really the same thing as the formula for r, where you're finding r is equal to the square root of x squared plus y squared. So for this particular example, if we want to find the absolute value of 3 plus 5i, we can find the square root of 3 squared plus 5 squared. Notice the I does not go into the formula. There's no I in the radical. And then we just simplify. So what I have here is the square root of 34. If I could simplify that, if there were a perfect square in there, then I would bring it out. But this does not simplify. So that's how you find the absolute value of a complex number. Before we continue, I'd like you to try finding the absolute value of negative 2 plus 3i. And you should get square root of 13 for that absolute value. The other skill I want to review with you before we actually start section 6.5 is solving for theta when we're given a trig ratio. And today it's really going to be tangent pretty much always. So to solve for theta, if you are using the unit circle, then you go ahead and find your solutions. And if you are using the quadrants and reference angles method, then you're going to look at your 30, your 60, or your 45 for your reference angle, and then you're going to use all students take calculus to determine the quadrants. If you think of or draw your 45, 45, 90, very quickly you can rule that out because the tangent of 45 would be 1. So we're definitely going to be using 30 or 60 here. And if we set up our 30, 60, 90, then the tangent of 30 is going to be 1 over radical 3, which is a match. So 30 degrees is our reference angle. And to place that in the correct quadrant, since tangent is positive, we want to be in quadrant 1 or quadrant 3. And the angle in quadrant 1 that has a 30-degree reference angle is 30 degrees itself, which I'll call pi over 6 in radians. And the angle in quadrant 3 that has that pi over 6 reference angle is going to be not 5 pi over 6, but 7 pi over 6, because we're going to go past pi. And those are the two answers we get here for theta. What I'd like you to do next is practice one of these on your own. So I'd like you to take a moment and solve for theta if you're given that tangent of theta equals negative 1. And the answers you should get are 3 pi over 4 and 7 pi over 4. We are now ready to start section 6.5, so if you have not been taking notes yet, this is where you want to take out your notebook and pretend we're in class. There will be certain topics while we're doing distance learning where the video might be sufficient. This is a lesson where you want to be taking notes today. So, trig form of a complex number is what we're going to be studying. So believe it or not, we're going to be combining I and trigonometry, things like sine and cosine. And that probably sounds very frightening and like it's going to be really difficult, but typically this is a unit where students score very well. As long as you have your skills for evaluating trig functions from the past, you should be in good shape for this. So standard form is when you have a plus bi, and that's why we reviewed that last week. And the new form is going to be called trig form. There's actually a third form called exponential form, but we don't learn that one this year. So this year for complex numbers, we have standard form and we have trig form. So trig form is brand new. Remember, z is just a label that we're using, so don't worry too much about z. And trig form is going to be r and then either parentheses or brackets, cosine theta plus I sine theta. R is called the modulus of z. That's a vocab word that I want to expose you to, but I really won't be using in the lessons. And the modulus of z is going to be the square root of a squared plus b squared, which should look familiar. It's just the absolute value of this complex number. And theta is called the argument. Again, I want to expose you to that word, but I actually won't be using that word. I'll just call it theta. And to find theta, we're going to be using tangent, and tangent is going to be b over a. We're going to go ahead and jump right in with our first example. And that's to write this complex number, -2 minus 2 radical 3i, in trig form. There are basically going to be 4 steps to this process. We're going to plot the complex number. We're going to find r, we're going to find theta, and then the 4th step is to write our final answer. So I do really strongly recommend that you always plot your complex number first. And when you plot your complex number, you don't have to worry about being highly accurate. You really are just doing this to figure out what quadrant you're in. So if you go left 2 and then down 2 radical 3, that's the location of our complex number. And remember that that complex number, -2 minus 2 radical 3i, it corresponds to -2 radical 3. So even though this is technically the complex plane where this is our real and our imaginary axis, we're so used to thinking of x's and y's that we can think of this as going left 2, like an x coordinate, and then down 2 radical 3, like a y coordinate. Okay, so we got our plot. Now we know what quadrant we're in. Our next step is to find r. So to find r, we're going to use our formula where it's a squared plus b squared, or x squared plus y squared. It's really the same thing either way. So we're going to have -2 squared and -2 plus radical 3 squared. So that's using a squared plus b squared. Or if you're thinking x and y's, it's x squared plus y squared. Same thing. Don't forget when you're squaring this to square the 2 and the radical 3. So here you should get 12. And we're going to get r is 4. And if anyone does recognize the special ratios here, you can skip the work for finding r, because the ratio here is 2 to 2, radical 3 to 4. So that's the same as your 30, 60, 90 ratios. There is absolutely no need to recognize that. But if you do recognize that, you're welcome to skip this part and jump down to r equals 4. Then to find theta, we're going to use tangent. Tangent is b over a, but it's still y over x. You can think of it either way you want. And if we set up tangent is b over a, b is -2 radical 3, and a is -2. That's b, that's a. If you're thinking of x's and y's, it's y over x. It's nothing new, it's just a new way to look at it. If we simplify this fraction over here, the -2's are going to reduce. We get tangent equals radical 3. So if you're using the unit circle, go ahead and think of the unit circle or draw it out or sketch whatever you sketch for the unit circle. If you're using quadrants and reference angles, you can use the 30, 60, 90 that you made before. And the reference angle here is going to be 60 degrees or pi over 3 in radians. For the quadrant, you actually don't even have to do all students take calculus. If you plotted the point to begin with, you already know what quadrant you're in. You are in quadrant 3, and the angle in quadrant 3 that has a pi over 3 reference angle is going to be 4 pi over 3. That's your theta. Your final step in this process is to write your answer. And our answer is going to be in the form r times cosine theta plus I sine theta, which is something you should memorize. But just by doing the practice problems that I'll give you, kind of like homework or classwork, I think that's going to stick. So I don't think you're going to have to work real hard to memorize it. You plug in for r, the 4, and if you plug in for theta, the 4 pi over 3, you have your answer. Next, let's do a second example going through the same process. So this time we're going to write 3 minus 3i in standard form. I skipped the label of putting z equals. I could put it there, I could not put it there. It's just the label, so it doesn't really matter if I put it there in the problem or not. So we're going to go through the same 4 steps. We're going to plot, find r, find theta, and then write our final answer. So first, in your notebooks, go ahead and plot 3 minus 3i to figure out what quadrant we're in. We are in quadrant 4 because if we plot 3 minus 3i, we're going 3 to the right and down 3. Next, go ahead and in your notebooks find r. R is going to be 3 square root of 2. If you recognize that you have a special relationship there, it's a 1-to-1 to radical 2 ratio because it's 3, 3, 3 radical 2. It has something to do with the 45, 45, 90. So if you do recognize that relationship, you are welcome to skip this step here. But if you don't recognize it, and it's okay if you don't recognize that in the entire unit, just do your formula for r. It only takes a moment. And next, go ahead and find theta. So if you prefer to use the unit circle, go ahead and do that. If you're going to find a reference angle, find your reference angle. And remember, for your quadrant, you actually already plotted, so you already know you're in quadrant 4. And what you should get here is you should get 7 pi over 4 for your theta. I did b over a and got tangent was -1. That reference angle is going to be 45, and we know quadrant 4 from our plot, so 7 pi over 4 is what I'm looking for. So to put our final answer, which is the 4th step, we're going to use r cosine theta plus I sine theta. Don't forget those parentheses, they do matter. And if you sub in for r and you sub in for theta, you have your correct answer. Now, a couple things I want to go over before we continue on our way is that there are alternate answers that are correct. So for example, I use 7 pi over 4, but you could use 315 degrees. Unless the directions say radians, you don't have to do radians. You can use negative pi over 4, that's coterminal with 7 pi over 4. So if you sketch 7 pi over 4, negative pi over 4 is coterminal. So you're welcome to use negative pi over 4 instead. And you could even do negative 45 degrees. Anything that's coterminal degrees or radians will work, but you should make the angles match within the answer. We do not typically do two different answers in the two different angles within that final answer. If you have two different angles here, that's technically not trig form. And the next thing I'd like to do is talk to you about what you're finding when you find trig form. What you're really finding is just a different set of directions. I mean, for example, the question I usually ask in class is, if you were going to drive from Wayne Valley High School to Wayne Hills High School, is there only one way to do that, or are there different routes you can take? Yeah, there's different routes. So you could tell somebody to go up Valley Road and then make that left onto Burdan and you get to Wayne Hills High School. That's not the only way to do it, though. Another way to describe getting to the same location would be to go up Nellis Drive and then take this road, which I think is Alps, and then you can make some turns and get yourself to Wayne Hills High School, or you can go this way as well. So just like there are different ways to get from Wayne Valley to Wayne Hills High School, we can get to a location in space by describing it in different ways. So this example that we just did, we came up with 3 minus 3i in standard form becomes 3 radical 2 times this quantity in trig form. These are really just two different sets of directions to the same location in space. This set of directions says, start at the origin, go 3 in the real positive direction on the real axis, and then go down 3 in the negative direction, go down 3 on the imaginary axis. And that's how you get to this point. So if I call this z, I can just label that z. So that's one set of directions to that location. Trig form provides us with a different set of directions to the same location. And this set of directions involves an r, which is the distance from the origin. I put that in my calculator and find out that the approximation for that is 4.24. And then for theta, theta is 7 pi over 4. So if we sketch 7 pi over 4, which is smack dab in the middle of quadrant 4, and then we go out about 4.24, so about 4¼ units on that terminal side, because that's what r is, it's the distance from the origin. This should be the same location in space as this. If we were to put these two on the same plane, they'd be that same spot. So hopefully that gives you some sort of idea why we might work in trig form, or the fact that they are actually equivalent. But we have 2 more things to do in this lesson. So we have just 2 more examples to go. And for our next example, we are going to write 4i in trig form. Now, this problem, we can do the same steps that we did before. We can plot and find r and find theta and then write our answer. But this one has a tremendous shortcut. And I'd like you to try to think of what that shortcut might be. So if we plot this first, this is 0 plus 4i. What we will see is that we have moved up 4 units on the imaginary axis. And if we simply look at that plot without doing any calculations, we know that r is 4, and we can actually tell what theta is as well. If you think about this as the terminal side of an angle, then that angle would be pi over 2. So we can write our answer in that format as 4 times the cosine of pi over 2 plus I times the sine of pi over 2 without doing pretty much any work at all. If you can plot that point first, since you're on an axis, that's when you're going to have this type of shortcut. If you're on an axis, you should be able to figure out what r is because it's the distance from the origin just by looking, and r should always be positive. And by thinking of this as the terminal side of an angle, you can find out theta without doing any work. Now, if you were to use the formula for r and the formula for theta, they do technically work, but they're really a lot of extra work, and I wouldn't go there. So if you wanted to use the formula for r, you could. You're still going to get r equals 4. And then this is the one you don't want to get involved in. You could technically set up tangent theta as b over a. So b would be 4 and a would be 0, but that's undefined. So what you'd have to do next is start looking at where tangent's undefined. So you're going to have to remember you're looking for y over x, where the x is 0. This does not sound fun, does it? And what you get are 2 locations. And then think about what you have to do to pick pi over 2 or 3 pi over 2 anyway. You're going to have to plot to find that out. So if you plot first, you can just go ahead and conclude that you're on the angle pi over 2 and save yourself a lot of time and energy. And our last example for today. For example 4, this time I'm going to flip things around. I'm giving you trig form, and our job is to write this in standard form. I think you'll find this is a much more straightforward process than going from standard to trig, because all you need to do is distribute the 6 and simplify. So the r, in this case that is 6, and then just evaluate those trig ratios or trig functions to simplify. So basically just work it out. So if we have 6 times cosine 5 pi over 6 plus I sine 5 pi over 6, you can distribute the 6 first if you want, or you can evaluate cosine of 5 pi over 6 and sine of 5 pi over 6 first. Either one's fine. So I think what I'll do is I'll distribute the 6 first. So I have 6 times the cosine of 5 pi over 6 plus I times 6 times sine of 5 pi over 6. And I could have done I times 6 or 6 times I. Multiplication is commutative, so either order is fine. And then when I go to find cosine of 5 pi over 6 and sine of 5 pi over 6, if you're using the unit circle, go to your unit circle, locate 5 pi over 6. The x-coordinate is going to be cosine and the y-coordinate will be sine. If you're using quadrants and reference angles, then you want to sketch the 5 pi over 6. And you can find out your reference angle is pi over 6, which is 30 degrees. So by using your 30, 60, 90 that you've already drawn today, you can find out that the cosine of 30 degrees is going to be radical 3 over 2. And the sine of 30 degrees is going to be 1/2. And make sure you check your SIGNs. Since 5 pi over 6 is in quadrant 2, sine should be positive and cosine should be negative. If I now go ahead and multiply, I'm going to get negative 3 radical 3 plus, this is going to be 3i. And once again, all you're doing is finding directions to the same location in space. So if we were to sketch 5 pi over 6 and go out 6 units to find this point, that location, that should be the same as if we go 3 radical 3 to the left and up 3. And that should be the same location as this. It's just a different set of directions to the same spot. And one last side note for anyone who had a little trouble with 6 times negative radical 3 over 2, just make it 6 times 1. So what you have is negative 6 radical 3 over 2, and this is going to reduce, and that's how I got negative radical 3 over 3. Thanks for listening. You can go ahead to the next task in today's classwork, and I will have another lesson ready for you tomorrow, or next time we're supposed to have class. Take care, guys.